Hey, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Alameda International High School. In this video, we're going to be working with still some circles, but we're not going to be talking about, specific parts of that circle. So some quick review for you guys. Again, that Greek letter theta. Make sure I can write it. It kind of looks like an O with a line through it. We're going to say, it's spelled like this, theta, is used to show an angle amount. So again, normally that's going to be in degrees. And so it's going to be, like I said, usually in degrees. Make sure that you can have that for yourself. Again, if our angle was 60 degrees, notice the little O in the top. And then it says the distance from the center of the circle to the edge of the circle is called the radius. We're going to say our radius R is going to be that distance from that center to the edge. So notice how it has it there. And then we're going to say the distance from the edge to edge through the center is called the diameter. So it has to go through that center for it to be called the diameter. And again, that's also twice the length of the radius. So we can say this, we can say D is going to be equal to 2 times the radius. All right, so anytime you're thinking about circles, try to think of pizza. A lot easier to work with, might make you a little bit hungrier, but always hungry to learn. So some new concept, we're gonna say let's say the sector. The sector is gonna be a region inside the circle. So we're gonna say that's gonna be that pizza slice. So we're gonna be talking about kind of like this shaded region, that's gonna be the sector. However, we're going to say the arc, A-R-C, is going to be a curved part of the circumference. So think of that as the pizza crust. So that's going to be that outside section around the perimeter. So make sure you're thinking, okay, sector is going to be the area. So we're going to say this is going to be area, where that arc is just going to be a line, a curved line more specifically. So make sure that you're seeing those differences. Again, remember theta is that angle amount and R is that radius. All right, so we're gonna say this, we're gonna say that we have to have some formulas for this. So make sure that you can have these for yourself. So we're gonna say that arc length, make sure it's on here, that arc length is gonna be like this. We're gonna say, notice how it's along that pizza crust, it's along that outside, and we're going to use that letter S. So we're going to say S is going to be equal to our angle theta. So we have the angle theta divided by 360, because we're talking about that part of the entire circle. So we're saying angle amount over 360, and then we're going to have times 2 times pi times the radius. So notice how it's essentially the circumference formula, but we're just using that angle amount. So we're going to say S is going to be that arc length. However, the area of a sector, notice how it's shaded and it has that letter A. We're talking about that shaded amount in red. So we're going to say, that's going to be like that pizza slice where the arc length is the crust. So we're going to say, all right, our area is going to be equal to, and then we have let's have our angle theta divided by 360, then we have times, and then we can have pi times the radius squared. We're taking that area of a sector, notice how it's very similar to the area of a circle, but we're just taking that angle amount theta and multiplying it by pi times the radius squared. So again, make sure so as always, be sure to pause for yourself, ask any questions that you may have, and be sure to label. Important part of that, again, make sure that you're labeling that part correctly. So now on the back, some examples for you guys. So it says at the top, numero uno, it says find the arc length and the perimeter of the sector. So a couple things, break it apart. So let's have, what are we looking for? So we're looking for that arc length. So we're talking about this part here from X to Y. You can notice how it's not a straight line. That's why it's an arc length as opposed to just from the point X to Y. So we're talking about from X to Y, that curved part. So you're gonna make sure you can have your radius R is gonna be equal to 6 which is going to be our radius, and then we have our angle amount theta is going to be 30 degrees. Once you have those two, make sure you can have that formula. So we're going to say that arc length S is going to be equal to, and then we have our angle theta divided by 360, and we have times 2 times pi times the radius. So let's plug in our things that we have. So let's see. Let's have our angle theta. So we're going to say S is going to be equal to 360, or excuse me, let's say 30. There we go. 30 divided by 360 is going to be that first part. And then we have times, and we have 2 times pi times the radius, which is 6. So what I would suggest you do is, again, make sure you can have all these in there. Again, you can take, let's see what 30 divided by 360 is, about 0.083. And what you can do is, I'm going to type it in exactly as it looks. So you can type 30 divided by 360. We have times 2. And we have pi, so second pi, and then 6. So if you notice, we're going to say, hey, that's going to be about that 3.14 for each of those parts. So we're going to say, all right, make sure you can have that in there. So we're going to say that's going to be about 3.14. So we found that amount from X to Y, that curved amount S. So then it says find the perimeter of that sector. Well, how do we do that? Again, make sure perimeter means add all sides together. So what do we know? Well, we know, hey, if we can kind of picture it like this, we're going to say, let me actually draw it down here. We have this curved, and then we have kind of a pizza amount. Notice again, 2 sides we already know from the radius, and then we're going to say that curved amount where the pizza crust is going to be about 3.414, and so we're going to say that perimeter is going to be these 3 added together. So you have 6 plus 6 plus 3.14. It's going to be about 15.14. So you can make sure, try those out. Try the your turn. Again, all you're doing, find the length of the arc length. So we'll say this outside amount, notice how it has the S here. We're trying to find that outside amount when the radius is 4 and your angle amount is 240. So you're gonna make sure you have your labels, find your arc length, and then the perimeter of that shape. All right, and the next one, it reads like this. It says find the area of the sector. So again, same picture. We say that our radius R is going to be 6 still, and our angle theta is 30 degrees. We said the area, again, we're talking about this shaded amount. This area is going to be equal to our angle theta divided by 360, and we have times pi times the radius squared. Make sure you can plug in your values for your variables. So we have 30 over 360 times pi times the radius squared. So we're going to have 6 squared. Again, make sure you're not multiplying by 2. Again, 6 squared. Sorry, 6 squared. If it would let me. There we go. 6 squared, 36. Again, make sure you're not multiplying by 2. 6 raised to the power of 2. You can type it in exactly as it looks. So we have 30 over 360 times pi times that 6 squared. Again, notice we're talking about that area amount. So we're going to say the area of this sector is going to be 9 point, and we can say 4, 2. And we're going to say centimeters. Let me put that label on there as well. centimeters squared, since we're talking about area. So you gotta make sure that you're labeling your parts, write the formula, substitute, and solve. And be sure to check with me as you get your turns done. That way you can make sure they are correct. And as always, super slam that subscribe button.